Welcome everyone to 2024, another quantum computing report update highlighting what to look for in this new year. Doug, please tell us what shall we have on our radar.
Okay, well, thank you, Michael. And first of all, Happy New Year to everybody. I wish you all a very successful and prosperous 2024. I think it's going to be a wild year. I think there's going to be a lot of exciting announcements and a lot of good progress being made in the quantum world this year. So we're going to have a lot of fun in covering it. One of the reasons I say that is because I saw some indications of certain things that happened at the end of 2023 that I think really portend more things that we'll see in much greater depth in 2024. So I will start with one thing, which is error correction. In December, error correction was certainly a big topic. I think there was a lot of press, and we wrote several reports on the Harvard experiment. But at the very end of 2023, there were a couple of announcements that really flew under the radar that a lot of people missed. The first was an announcement from the French company Alice and Bob to tape out a chip that utilizes their cat qubit technology. And cat qubits are a way of perhaps simplifying the error correction codes by basically taking using a hardware architecture that eliminates or pretty much eliminates what are called bit flips, so that the error correction code only has to worry about phase flips. So the key announcement there was that their goal is to have a chip, or at least a small system, that has 6 nines of qubit fidelity. So that would be in terms of error rate, it would be 0.0001% logical error rate. So they taped out their chip in December. That means the chip's being fabricated now. Whether or not they meet that with the first revision of the chip, we don't know, but we wish them the best of luck. I will also mention, by the way, that Amazon, in their hardware efforts in Pasadena, California, have a very similar thing. They're also working on cat qubits. One of the VPs teased us a little bit at the AWS reInvent conference in Las Vegas. He just held up something and said, we'll talk more about that next week or next year, but we'll be very anxious to see what they have to say. The other announcement on error correction was an announcement from the U.S. DARPA, Defense Advanced Projects Research Agency, that they have selected 2 companies, PsiQuantum and Microsoft, for their phase 2 of their unexplored systems project. And the important thing there is that in phase 2, the goal will be to demonstrate by the end of phase 2 an error-corrected quantum computer. So we'll see how well those 2 companies do. I will mention that phase 2 completes at the end of March 2025. So if you were to ask me when we might see a error-corrected quantum computer, I would say March 31st, 2025. May only be a few qubits. It's really for demonstration purposes, but definitely there's a lot of efforts going on there. Another trend that I think we're going to see a lot more of in 2024 is hardware sales that are not non-cloud. You know, if you'd asked me 3 years ago, what's what I would call the distribution channel for quantum computing, I would say it's going to be through the cloud. But we are seeing throughout 2023, we've seen more and more cases where people are selling hardware or selling systems for on-premise use. And it's really going in 2 directions. The first direction is what I would call for research. In December, Rigetti announced a little device called the Novera QPU, which is a superconducting chip that they would sell to research agencies and U.S. government agencies and maybe even universities, that those companies and those organizations would put together their own dilution refrigerators, their own control logic, and they would go forward and build their own quantum computer. IQM this fall announced something called a Spark, which was a 5-qubit device for very similar purposes, very similar research purposes. INQ also announced a couple sales or a couple pending sales to the Air Force Research Lab. Again, more for research, I think. for them to figure out how things are happening. But at the same time, we're also seeing companies pursue more sales, direct sales to data centers. Um, IQM, for example, is taking that approach. They announced machine at VTT, and they're putting in I think, 54 qubit machine. Oxford Quantum Circuits has also been announced several things. So we do expect to see more sales and more external sales, either on premise. I think the research market might be a little bit limited, but there may be a handful more of those types of sales, and it's not all going to be cloud anymore. So that'll be an interesting development that we'll watch. Um, at the same time, we're starting to see a lot of government interest. A lot of governments are announcing. We're still very waiting to hear what the U.S. government does. The National Quantum Initiative Act needs renewal. It was approved by a committee in the U.S. House of Representatives, but it still has to go through the full House. It has to go through the Senate. It has to be signed by the president. So there's a lot of things happening there, and we certainly wrote several articles about what's happening, and we'll continue to write that as it makes progress. But at the same time, other governments are ordering systems. I think that is a really good way for a government to promote quantum computing in their country is by sending out POs. Nothing motivates a company like a PO, and they have to deliver something. It may even be better than a grant. So I think we'll see a lot more of that coming in the future. Getting back to hardware, we saw a couple of announcements of I'll call machines that are breaking the 1,000 qubit barrier. This fall, we saw Atom Computing announce, I think it was 1,100 some odd qubits that'll be available, I guess, now in this quarter. IBM also announced a processor they called the Condor that had about 1,000 qubits. The only thing I would mention about the IBM is that it is a test vehicle for internal use only. Our understanding is that IBM is not going to make that available on the cloud. It's really for their own internal engineering use to help develop the technology they need for larger future machines. But we do expect to see several other companies announce 1,000 plus physical qubits in 2024. So that will be a significant development. In parallel with that, though, there's also continued work to improve the qubit quality level. One thing we've been noticing in the superconducting area is the trend towards moving towards tunable couplers in the qubits. Rigetti's future machines are going to have a tunable coupler. The new IBM machines are going to have a tunable coupler. It was pioneered by Google several years ago, but that will significantly improve the various metrics of qubit quality and reduce crosstalk. And a different approach on the superconducting side is a different type of qubit that's called a fluxonium qubit, as opposed to a transmon qubit, which is currently used by IBM, Google, and the other. Fluxonium also appears to have a better intrinsic qubit fidelity. There are two companies we know of that are pursuing that approach. One is D-Wave, and the other is Atlantic Quantum. So we're very interested to find out how well those qubits do. There was a small press release again last fall from D-Wave about some of the early results. It looked very promising for the Fluxonium qubits. And finally, on the software side, there are two trends I think that we continue to look at. One trend which has come about really over the past year is more and more of what I would have called the traditional quantum software company are now pursuing various types of AI and various types of quantum-inspired type of projects. And those projects certainly have a lot of value. We do tell our clients that at the end of the day, a CTO or a CIO at one of the user enterprises, they don't care how a problem is solved. They just care that it is solved. And certainly AI or some of these quantum-inspired approaches can solve problems today, which is, of course, what people always want. So some of these companies that were exclusively quantum have now doing at least some projects in in those areas. And when I say, our view, by the way, of something that is not a quantum software is if it does not take advantage of entanglement or superposition, then you would somewhere lie in the classical area. But companies like Sandbox AQ, Zapata AI, who actually renamed their company, um, QCR, Multiverse, they're all working on various forms of those projects. So that will be, helpful to those companies. It'll certainly bring in revenue for them. I don't think any of them have given up on quantum. As the quantum hardware gets better and better, they'll certainly do more and more on the quantum side. But it is a way of achieving revenue and getting cash without having to do another round of funding. And then finally, we'll just see more and more partnerships every day. We're announcing partnerships uh, between the software companies and the hardware companies, or the software companies and the end users. Various numbers of POCs. I think that will continue to actually increase in 2024. People are always going to try to reach for quantum advantage. And the thing that I will see as key is if someone is using quantum if an end user is using quantum in a production mode. In other words, they're doing a run every day or a run every week to do something worthwhile, as opposed to doing it once just so they can write a paper. So, we'll keep our eyes open. There's still certainly a debate in the industry about whether people will be able to achieve that. Some people say you're going to absolutely need the error corrected machine. Other people say we'll be able to do something with NISC. So it'll be interesting to watch over the next year. I do think there may be some people who they're able to achieve something relatively useful with NISC, even if it doesn't blow away the classical solution. They may use it just for the novelty of it. So we'll have to see. Anyway, so that's just some of the key trends we see in 2024. As I said, it's going to be a very exciting year. We're looking forward to it, and we'll continue to bring you the news week after week. So thanks so much, and good luck.